All right, we're back. I'm back, and hopefully you're back too. And this segment, I looked around and I could not find my PowerPoint on abstraction, so I'm going to wing it without the PowerPoint. So I'm sure you won't mind. We're going to turn.
Like it.
You like the PowerPoint?
No.
I don't like the PowerPoint either.
No.
So we're going to talk about abstraction, and I'm just going to talk about it and show you the ins and outs of abstraction and what it means to abstract a class. It's really easy. Actually, we sort of talked about it with the PowerPoint for the interfaces. So I've given you some of the fundamentals. Not an interface. This is an abstract class, just like any other ordinary class, however. So I'm going to work up the same example. Let me find it.
Put the abstract this morning.
Did we? We did interfaces.
No.
Did we do abstract last time?
Abstract.
Because
Just comparison between interface and abstract.
Yeah.
We did some couple of classes or just one class or two classes for abstract.
Did we write an abstract class last time? If not, I'll spend a few minutes on it. Some
Yeah.
people are saying yes, some
Yeah,
people are
that's
saying
fine.
no.
No,
You did?
that was just to show that if you
Yeah.
if you don't implement the interface, would you make
Yeah.
it course?
If you already know about abstract classes, don't worry about it. You're gonna hear it again. Just by tune me out. Go back to lunch for another half hour. I don't think I've covered abstract classes, so we're gonna do it now. So an abstract class, we can't make an instance of an abstract class. That's about all we've heard so far. So instead what we do is we use it as a base class. And it's a base class that's going to be implemented. So if we're not going to make any people, in this particular case, I could make person. Or I could make a new class and make it an abstract class, which I'm going to do right now, because I'm going to leave this alone. We're going to make a new one. It's going to be called a human. Or how about animal? We'll make an animal class. Then we can have person, and person's an animal. Or human. I'm going to make an animal class. So animal's going to have like, like weight and height and, I don't know, stuff related to an animal. And maybe it's going to be a grow, stuff like any animal would do. We'll make it an abstract class. So I'm going File, New, because I want to make a new class. Class. This time I am going to select the button that says Abstract on it. And I'm going to call this one, call it Human. People are human. Animals. Because then I can make dogs and cats if I want to do it here. So I have person. So this one I'm going to call it a animal. And I'm clicking on public because it is public. And I'm clicking on the abstract button in this particular case. It's going to come from objects. It's going to be our base class that's going to be underneath human. So I'm going to build it underneath. Just kind of show you can build it in the opposite order. Don't need any constructors and don't need anything, so I'm just going to go here. But just in the future, if you click this button that says constructor from superclass, it's actually kind of a cool thing. You might want to click on it, check it out. It'll automate the constructor creation for you. There's also a menu item that does the constructors for you as well, but it's kind of like using a calculator to learn math. When you get familiar and you know what constructors are, go ahead and start playing around with those automation features. So one thing you might notice is it says public abstract class animal. So now we have the word abstract in there. And the abstract is basically telling us that this is an abstract class. Well, there really is no difference between that and this. If I take the word abstract out, I have just a regular old class, public class animal. The difference is that in an abstract class, we have at least one abstract method. So I'm going to make a class, and then I'm going to I just took it away from being abstract, and I'm going to make a new class. So we're familiar with this already. So an animal, I'm going to have in here a double weight, and let's see, integer, height, I don't know, for lack of better creativity, I'm going to put in here a height as well. And I'm going to put, so I have some data members in here, and I'm going to put some methods in here. I'm going to have one that's going to be void. So my method here is going to be public void grow. And grow, well, the height, let's say, so let's say this is, going to be like height plus plus as an example or something. Weight plus plus, I don't know. We're going to increase it, I don't know. We could put some constructors, some multiple constructors in here if we want. We know how to make a class, I hope. This is what we spent the morning reviewing. So let's make it abstract. To make it abstract, it means if I don't know how exactly we're going to grow, I'm going to make this one here a function prototype. And so I'm going to put a colon at the end of this. I'm going to get rid of this. I'm making essentially an interface here. But instead, I'm going to add the keyword abstract. And if I make it abstract, void, abstract grow, abstract public extract, hold on one second, public abstract void, what's going on here? Remove abstract modifier, yes, remove the modifier. Well, because, oh, you know what? This is going to try and help me, isn't it? This is what it's doing. It's helping me. It's essentially, once I do this, once I put the word abstract in here, there's going to be two problems that occur here. Once you have one abstract method in a class, the entire class has to be abstract. So either I take this abstract away and I make this into a regular method, which is what it wanted me to do a few minutes ago, or I say, no, I don't want to do it. I come up here and it says make type animal abstract. So if I make the animal abstract now I'm okay. I can have other methods in here too, like for example, I can have shrink. So, oh, actually, let's make a morbid one and we'll call it die. Well, let's call it shrink. We'll just call it shrink. Public void shrink. And shrink is going to take height and have it equal this dot height and have it equal to 0. And then we're going to take this dot weights and have it equal to 0. Now, classes that are inherited from this can still use shrink. And then let's just make because I don't want to bother with constructors of inherited class, I'm just going to initialize this information to 0. So I'm going to make a constructor of animal. And we can have a constructor as well. Even though it's an abstract class, it works just like any other class. So this is going to be, let's just do here, animal. And my animal here is going to say this weight is equal to 0. And this height is going to be equal to 0. So I guess this is kind of like born again. This one down here says shrink. Actually, I'm going to call it born again. Born again. It's a born again animal. Alright, so trying to humor things up here a little bit. So I got a method that's implemented. I got some data. I got a method that's not implemented. I can have as many as I want of both. So I can have another one here. I'm just going to put one in here, grow. So now I'm going to use this one. And person is going to inherit animal, because person is an animal. So I'm going to save this one here. I'm going to go over to person and say class person extends animal. And I'm going to get some error messages. And here we go. Let's see what happens here. Something about the unimplemented methods, I would say. It says add unimplemented methods or make type person abstract. I could do that if I wanted to. And what am I going to do is I'm going to basically delay my implementation. Because aren't all employees human? So I could do this. I could say make person abstract. Now I got two abstract classes. I have abstract person that's extending abstract human, or animal, excuse me, animal. So then now I go down and I look at, well, what's going to happen here? I'm going to save it. I'm supposed to get an error message eventually in employee. And so I'm going to go up to employee, and I'm also going to have a problem with main, because main's making instances of those things. So if I go over to main, I can see that person is going to say, can I instantiate the type person? So I'm going to say, okay, I don't want to make a person then. But it's okay to make a reference to a person. And as we've seen, we can make a reference to a person we already made once we make an employee. Employee is not going to be abstract. We're going to implement that method to grow, which is that abstract method that we have left over. We're going to put that in person. We're going to put that in employee. So down here we're going to have the same problem, so let's get rid of this guy here, and instead of person A is going to be new, well, let's just comment him out right now. We don't need that one, we don't need this one here, we don't, I probably should just take it out. Here, I'll just take it out of the code, actually. We can still have that reference to P, it's no problem at all, so that fixes our main. Not that we had to fix it right now, but it's not a bad starting point, just so we can have something to run eventually. So now if I hover over here, it's going to say, do we want to make employee abstract? We just keep going abstract, abstract, abstract because of that one abstract method. So eventually we're going to say, no, 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 I'm done being abstract. I want to make an employee. So it just means we're never going to make any people if we keep person, if we make that abstract. So I could have made person a regular old class and implemented that method, but now I'm going to say, here, add the unimplemented method. And if I add the unimplemented method down here on the bottom, I see this new method that got put into place here that says grow. And I don't necessarily need this extra stuff that was put in automatically. But I could do this. I can go this dot height plus plus this dot weight plus plus. And we're wondering, where did the height and weight come from? Well, it's the same as before. We still have it. So then I'm going to say, okay, and then I've saved it. So if we had, for example, so we have employee, and an employee, which is also person, right? So let's say I took animal. Let's put another class in here. Let's make a dog that extends animal. So, and a cat, because remember I was talking about dogs and cats. Those are all animals. So now I'm going to go back to my hierarchy. I'm going to go File, in New, Class. And this is how you pretty much get the concept, is you just keep making more strange classes and you see how it's going to work. And this is going to be dog. Dog's going to be public, and it's going to extend human or animal. Excuse me, not human, animal. Dog's not a human. Dog, public. Alright, that looks pretty good. I go into dog, and I hover my mouse over here. It says add unimplemented methods. Okay, because remember, animal's abstract. So we put grow in here. And this method could be different. This one is going to print out something like system out dot print line. Dog is growing. Or something like that. But I don't have to inherit. So here he's done. I don't have anything above the dog. I can have another one. Every method that, every class that I inherit from animal will have to have that method in there. So I'm going to make another one just because I want to show you something here. But new class. I'm going to make a cat here. And this is going to come from animal. So now cat's going to have the same thing. It's going to have that unimplemented method put in here. And I guess to say, now I'm going to grow the cat. System.out.print line. Cat is growing. So now my dog and my cat and my person is having this stuff here. So I'm going to go, yes. And then later I decide, well, what about person? I want there to be a person. I can always do this. I can actually go in here and I can say, well, I want to take out, because remember animal is abstract, but I want to make person now. I want to make person not abstract because I want to make an instance of the person. I can come over here and say, implement the method. Now I'm going to have it implemented down here. I'm going to say person's growing. Person is growing. So now the person's growing, and the cat's growing, and the dog is growing. But what happened back here with the employee? The employee still has that method over here. Grow. So it's still got a different implementation of it. So I'm going to print something else just so when we run employee, we can see, is that going to, if we treat it like a person, then we're going to get a different grow, then we'll get an employee grow, essentially. because we have two different instances. This is overridden. So we took that method, even though it was abstract, I'm just trying to show you that you can use it with some flexibility. Everybody's got a grow method. So I can make a cat, a dog, a human, a person, a person and an employee, grow them all, and they're all going to have their separate grow. So they're going to have their own function. It shows over here. I'm going to leave this alone here. I'm just going to go system out. Print line. Employee is growing. It's not going to remember all these objects here. So I'm going to save this guy here. Save this guy here. Come over to main. Although I removed it, I could probably put it back in here. Actually, I'll just do it this way. Person P is equal to a new person. P.grow. Cat C is equal to new cat. C.grow. Dog. D is equal to new dog. D.grow. And last but not least, that employee. We've got employee Peter already made here, so I'm going to leave him in here. Oh, I got a teacher in here too. Actually, let's leave the teacher in here. Teacher comes from employee, so teacher's got grow in there too. So then after these guys get made here, I'll just leave these guys in here because they're already done. And then I can go E.grow and T.grow. Kind of tedious, but I did that on purpose. It doesn't really matter what object it is. Everything has a .grow on it, which is some of the reasons why we use abstract classes. Kind of like the shape and the area. I'm going to show you in a few minutes. Everything's got an area. Everything has, calculate area. Okay, so if it's a circle, it's got an area. If it's a square, it's got an area. There are two different implementations of the same method. You make it abstract. You implement the method. It makes everything consistent. Makes everything abide by the same kind of protocol. Very similar to an interface, isn't it? Kind of, sort of, yeah. Except for in an interface, we can't change any of the data. Here we can change the data, and we're changing the data in the grow for the employee. We're going weight plus plus, height plus plus. So we're making the employee grow. So if I run it, we have interesting results. Not really that interesting, but let's see. Fascinating results. Oh, I still got that other thing going, don't I? I still have a bunch of other messages, but the person is growing, cat is growing, dog is growing. Employee is growing twice. Because teacher's an employee. Teacher 2 parameter was done. Employee is growing. Teacher doesn't have it. Teacher doesn't have its own implementation, but employee does. So, which is good because that's what I kind of wanted to see, and it worked, which is good. So if I go back to teacher and I take a look, I see that this is not abstract, employee is not abstract, and I see no grow method in here. So now for the teacher it says employee is growing. So I'm inheriting the method, I'm not overriding it. Employee is growing because I took that grow method. So if I go into employee and pull out that method, just comment it out, I'm probably going to get a person growing after that. Because I'm no longer overloading or I'm no longer complementing the behavior. I'm going to get the previous behavior that shows up. So if I come in here, I've commented out the method that was overloaded in employee, and now I'm going to implement the one that's in person. So now if I run it, I'm not going to get anything that says, I got person in here. Person name, oh no, growing. Cat is growing, dog is growing, person is growing, person is growing, person is growing. Because inside of employee and inside of teacher, I have nothing. But inside of person, I have person is growing, person is growing. So I didn't implement it. So instead, I'm using it from the inheritance without overloading it. So you can still overload, lesson to be told here, you can still overload abstract methods. It's just that you're delaying the implementation until you're actually going to use it. So you can have a base implementation and it can still work, which is different than what you get in C++. In C++ we have this thing called virtual, and we have this thing called pure virtual. We don't have pure virtual in Java. Pure virtual is delaying the implementation till the very last minute, which is in the last instantiation of that object, and making only the last one available at runtime. In Java, we have everything available. So we have the ability to cast out in C++ as well, but long story short, we have to overload it, and we have no way of actually determining without overloading. Otherwise, we're going to get the previous class. So if, for example, this was a shape, and then we had a triangle, and we had a shape that was a square, and we put an area inside a shape, the area would run for our triangle the same as it would for our square if we didn't implement it. There's no way of requiring. Once it's done being abstract, it's done. So people make everything possible abstract in the lower bases, especially if there's something in there that needs to be implemented. Because if it's not implemented, we're going to get the area of a circle that's going to be the area of something else, but not a circle. Because we wouldn't have implemented that area of a circle if we inherited the circle. So let's take a look at that circle, unless we have questions about this one. This one has the abstract class of the animal. I removed the abstract class of the employee, but I could have made it abstract. It just depends. If you're not going to make an instance of that object, you're not going to need it. I'm never going to make an animal. So if I try to make an animal, I'm going to get an error message in this. So let me close this one for a second and show you another one. Let me show you the shape, actually. What have I got in here? I've got method overloading. I'm going to show you in a few minutes. We have shape, abstract class shape. Abstract class shape has a shape color, and it has a constructor shape. And we have a set color and a get color. And then we have an abstract double area. And then we should be using shape in something, and probably point. Yes, public class point extends shape. And inside of shape, well, you lost your chair. Inside of shape, we have static integer x and y for the 2 points for the, point. 2 points determine position on the grid. So point x is 0, y is 0. Area here, we're going to return 0. We don't have an area of a point, but if we made a square on top of a point, then we would have an area that we could fill in, so we can just leave it. But we've implemented this area here, which is the reason why we used it as an abstract. So if this shape, I don't believe I have any other shapes in here. This is a static cube. We're not getting to this one yet. We're not getting to that one yet, but let me just see something real quick here on my vehicle. That's a vehicle. No, I don't have any other. Let's see, cube. Cube, no, it's just a cube. Well, you could easily create another shape, and eventually in the shape implementation, you'd add the form. Here, let's just create another shape. What do I want to create? Square. I can calculate a circle. No, let's not do a circle. Let's just height times width for the area. Let's do the circle. Let's do the square. So let's see. I'm going to go ahead and create a new class here, and this one's going to be called square. Oops, square. Square. And it's going to come from shape, and it's going to be public. I'm going to add it to my big old project over here, and immediately it's going to say add unimplemented method. I'm going to go, yeah, what I get? Area. So when I make a new instance of this square, I don't think I have a main, but I can just create a main real quick actually. In here I'm going to say, what did we have? Height times width actually. Let's just return height times the width, and we're going to have a problem here. what is it? I have to think of this language here. No, it's it is a star. And let's see what's going on here. We don't have local variables. Yes, we do. Where's shape? Shape. Shape doesn't have a height and a width. So let's do that here. We have an area in here? No, wrong one. Points. Point extended. But we put the area. Shape. Am I extending from the wrong one? Oh, here's area. We have area. We have area. Let's just put a height and a width. Actually, let's put it in here. It's a square, right? So we have a height and a width. So let's put it in here. So public height. Public. Whoops. Height is going to be a double. Let's just make it an integer. Oh, it has to be. Let's make it a double. Public double. What if I misspelled it again? Double width. Wait, width. Height and width now has returned. So now we have the area. So then we say, well, let's just make another class. I'm going to call it, let me save this one so it gets the red thing goes away. So square now has the area implemented. So I can make an instance of square. And now here's another question people usually come up with is, you know, how do you, I have more than one main in this project actually. So if I wanted to create a new driver program, I got like 5, 6, 7 different driver programs in here because I have it all stored in one package. I could just arbitrarily just create a new driver. So new class. I'm just going to create a new driver program. So I'm going to call it my new driver. And in my new driver program, because I'm in the same package, I'm going to click on here, public static. I'm going to press OK. And then in my new driver program up here, in main, I'm just going to make an instance of this thing I've done. So I'm going to say square, my square is equal to new square. New square. You know what? I better fix square though because I didn't set anything. Because here's what happens with a partial implementation. I'm going to get some extremely weird message because I didn't set the height and the width. I just declared it. So if I go like this and go system out dot print. Jesus, I print line. Well, this is why I don't type. What am I going to print out? I'm going to print out my square dot area. Area. This is gonna be interesting. Let's see what happens when I run this sucker actually. I run as a Java program. Should get some weird number being printed. No, 0.0. It initialized it to 0, 0. Which is kind of not so good. Because here I can just go square. No, let's leave it, make it a default constructor, then we don't have to do anything. And set the height is equal to 12. And the width is going to be equal to 36. Now when we run it, it will actually go back through and recompile this piece of the puzzle that's part of it. Now I got 432. I'll go a different area. So that's everything you need to know about abstraction. Actually, it's not too hard of a concept. You just make an entire class abstract when you include an abstract method. If your class doesn't have any abstract method, can you make it abstract? Yeah. Well, why would you want to do that? Like maybe you want to prevent people from making an instance of it, maybe. Well, you could do that. So. If I were just going to tag it, I'd use an interface for it. If I were going to prevent someone from implementing it, we can't implement it yet, it's abstract. Then we could. Well, if I go back, I'm sorry? Yeah, but you're not requiring them to, unless it's abstract. You can implement them, you have to implement the methods. If you don't implement the methods and it's an abstract class, you're going to get a warning that says, hey, you have to implement these methods. If you make the class abstract, let's see, actually let's just experiment here real quick, because we'll go back in and I'll take animal away and I'll make the animal public class animal and get rid of this abstract method over here. Oh, wait a minute. We're going to get rid of the abstract method, but I'm still going to make the class abstract. So I have an abstract, but I don't have any abstract methods in the class. Then over here, I'm going to get a really interesting thing that says remove override notation. Sure, why not? Because we're not overriding anything anymore. So now we're going to have our own method that's going to be implemented. So we're not overriding, we're making a new method, and the new method's called grow. And the next class is going to have the same problem, and dog is going to say the same thing because that's in there. If normally that's not going to be in there unless you use the automated system actually to have Eclipse actually create that method for you. But this one's not going to be in here either. But now what are we doing? We're relying upon the programmer to put grow in there because out in main we're going to run it, and it's essentially going to like you know, expect that we have all these grow methods, and if we don't have all the grow methods, then there's nothing to stop the programmer for not putting it in. So I don't know, it can be used to enforce rules, it can be used to ensure consistent behavior, and also to delay the implementation of methods that would make no sense earlier on, like a shape. There's no such thing as an area of a shape, because you don't know what kind of shape it is, until you make an instance that's going to inherit something about that shape. You know, until you, make an object that's going to use that shape, you don't know how to calculate the area. But that is your example on abstraction. Any questions on abstraction in the language? Yeah, so I'm going to segment this bit. Yeah?
I'm not understanding the actual use of it.
The use of it.
When you created a class, you created an abstract procedure, abstract method actually. So
If the abstract method's in there,
yeah. So you created a grow abstract method, and you have the different definitions of that method in all the classes. When you're calling it is actually printing the different, so definitely they are behaving differently.
yeah.
I mean, I cannot.
So cat's grow is different.
I can have the grow without the abstract class. I can have grow as a method if I'm in all different classes. I can give the name, but still I can get the same behavior. Okay.
Correct. So you're making it abstract because you want to have the method. All animals have a grow. All animals grow in general. So you want to make sure that there's a method in there for growing, and you want to make sure that the programmer is going to implement that method.
Okay.
Then you make it abstract. But isn't that the same thing as an interface? I mean, we use an interface because we want to make sure that people implement the grow method. I could easily have made an interface. But then, let me tell you what happens with an interface, because here, we'll just change this, make it into it. Yeah, actually, this is interesting. I changed it back, so animal is abstract now. And it doesn't really matter, I removed the overriding methods, but this behavior is still acting the same. Let's create an interface and call it grow, and have a method in there called grow in the interface. And we'll see what happens with this one. So we're going to go file, new, file, new, interface. And the interface is going to be called grow. Why not? And it's just going to have a grow method in there. It's going to be public, and I'm going to say, okay. So here's my grow. And then inside here, I'm going to have a void grow. And I can put public in here too. Let's see, public. So nothing really changed yet. So let me go back to animal. Well, let's leave animal alone. Leave him alone. Let's go into a cat here. Cat's pretty small. It extends animal. Now it's going to implement. Did I spell that right? Implements. Oy vey. Implements grow. No error. Nothing, because I have a grow. But I have two grows. So I have it in there. But let's say, for example, we change it. So let's leave the grow here. The grow is in this one. We go back to animal, the abstract class, change the grow. I'm going to call this one eat. Animals eat. So now we have an eat method. So anything using this one here is going to come back. Let's see, but we have cat. It's going to complain about my eat. So I'm going to have to implement the method for the abstract class for eat. But is it complaining about grow? It would complain about grow. If I take grow out, it's going to complain about grow now. Nope, still working on eat. When it gets around to eat, it'll do grow. So then, let me show you though. There's a reason why I'm doing it this way. All right, so in here I'm going to implement the eat. I'm going to do it this way because it's a little bit more automated. So I'm going to make unimplement the method eat. Actually, I can just leave it blank. I don't have to put anything in here. So then cat's okay. What's wrong with dog? Dog has got unimplemented make dog abstract. Well, that's because
we remove go.
eat's not in there. Why isn't eat in there? Because we extended animal. Animal. That's interesting. So dog, class dog extends animal. It complained about eat. Cat extends. Well, it shouldn't complain about eat. Why is dog complaining? Class dog extends animal.
Yeah, because eat is abstract.
But it's an abstract method of the interface, and the interface. Did I add it to animal?
Yeah.
Okay, that's what the problem. That's the problem. I put it in the animal. Okay, that's what the problem. Okay, I thought I put it in the interface for a minute there. Okay, so if we fix it up here, I have to do the same thing here. We'll just fix it up here real quick so it makes it so it compiles correctly. And now you think, well, what have I done? It seems like I've added a lot of stuff for nothing. So problem is this. This can extend animal, implements grow. What if I wanted another one called print? And I wanted to keep the concepts separated out by concept? Then I would do another interface. And the interface here would be print. And I'd have them all implement print. So if I went in here and did this, new interface print. And then print has got something in here, I don't know, public void, how about print? So it's got, method has a constructor name, I know it does, print me. Let's just change it, make it print me. And then I can do this. So chances are I'm going to have multiple interfaces. And if I have multiple interfaces, I can come back up to animal as an example. Class, no, where did I actually do it? Cat. Implemented grow, comma, print. And then I can go comma, something else, comma, something else, comma, something else. But I can't do it right here. I can only extend one animal. But animal is going to be functionality. Interface is going to be compliance with common methods, if you want to think of it that way. Common methods would be print, open, close, I don't know. Anything that would be common among a ton of different types of things. These would be a ton of different animals. So in here it's going to have me add unimplemented methods. I'm going to add this unimplemented print me. So I'm going to save this one here. Now I've got two interfaces along with an extend abstract class all working together, and it allows me to essentially implement multiple interfaces. Is it all accomplishing the same thing? Unfortunately, yes. Is it confusing? Slightly, only because you're wondering, well, there's a lot of people that will use just interfaces and no abstract classes, and there's times in which you'll use some abstract classes. And we're going to see it with collections. So actually, let's look at collections now. because now it's actually a good translation. Yeah, transition.
Can you go back to the interface flows?
I can. The interface for dog or print? For print. Yes.
So we can never have implementation of the method here in the interface.
Implementation? Yes, we can. We
And-
implemented it in cat, right down here. You can put a system out, I'm printing, or something.
No, not
Oh, I'm
on
sorry.
the interface. On the interface,
Yes.
maybe we have a grow interface, right? So
Oh, let's go to grow. What happened to grow? Oh, here it is. I see it. I need to make this bigger. This font is huge. I need to make this font bigger.
grow is not growing. So here, I mean,
You mean like this, like here, public void, a shrink.
okay.
And then
not short portion.
We can go over here. It says remove method body.
Oh,
We can't implement something in an interface. An interface only has prototypes in it, and the data is static, constant, final,
okay.
which means we're not going to be able to use this like a class. Abstract, that's another good difference actually. An abstract class you can use like a class. Just can't make an instance of it.
Okay.
But you can make an instance of a class that's derived from the class. Let's cancel those
You cannot
changes.
make instance of abstract class.
Cannot make an instance of an abstract class. So out here, what did I make abstract? So I remember here, animal is abstract. Anything else abstract right now? Nope, cat's not abstract. So animal, if I go out here in main, well, I had the same problem actually before with person. Come up on the top here and I say animal A. It's not going to complain. But if I go A is equal to new animal, then it's going to complain because it's going to come back and say can't make an instance, cannot instantiate a type animal. But I could do this. Isn't a person an animal? So it is. So then I can go down here. I can go A is equal to animal P. And now A is a animal version of P. So we're going to go back and say, well, didn't you just say you can't make an instance of an abstract class? I can't. But it's not abstract anymore because P implemented it. P implemented the abstract class. So now I can go p.grow or whatever. Actually, p.grow is on here. Do we have a grow? No, A. Let's go a.grow. If I go a.grow, it's going to come back and say, can't create method grow in type animal? Add cast to A. Let's add cast to A. Person A. Animal doesn't have a grow, but person has a grow because grow came from the abstract class. But it wasn't implemented in animal, it was implemented in person. So now I've taken person, treat A like a person and then run the grow on A, is what I'm doing here. So if I run it, A should be a person, and if I take out this stuff here, I'll just leave it. It's the first one that's going to be printed out. The first grow is going to be for A. So if I run it now, it'll be a person is growing. Person is growing. But it's an A. But we're casting it. So we're casting it back, actually. We're taking an A, which is an animal, and we're casting it back to a person. Why do we want that? I don't know, because we want to keep them all as animals. We can make them all equal to animals and then cast them back as what they're supposed to be, to use functions from the hierarchy. But when you're referencing it as an animal, you don't have grow in that particular case.
What is it actually stopping to create the instance of an abstract class?
It's the only thing that's really stopping is the compiler,
Unimplemented method.
but it's unimplemented, so it doesn't know how to create it. You have an animal, this abstract eat. This is why we can't make an animal. We don't have a grow in here. But we can do this one. The abstract class can implement. If I spelled that correctly, implements. Ah, there we go. It can implement grow. Is it grow? It's grow. I think it is because it didn't give me an error message. So now I have animal that's implementing grow, but I don't have a grow in here. So eventually, Wow. Was I an animal? But I'm not implementing it. Ah. So instead of me, what this accomplished was, because we can't make an instance of this anyway, it can't be implemented. If I did it here, each one of the derived classes that's not implementing grow needs to implement grow, because it's still abstract. So animal, let's go to cat real quick here. Take out grow. No problem. Take out this method. Should have a problem. It's going to say add unimplemented method. If I add the unimplemented method, I get grow. Even though I didn't
Because it is an
implement
animal,
the grow. I put it in the abstract. So it carried from animal. I don't have to put it in here. If I implement an interface in an abstract class, I don't have to implement the interface. I just say I'm going to implement it. And it just adds more to it to be implemented further down the road. So we implemented it in cat. So if you don't want a big old line of stuff that needs to be implemented, then you put it in the lower base class, make the class abstract, put all the interfaces in there. And then when you start inheriting classes from it, you're like, what? This method too, and that method? Where'd this all come from? And then you get really convoluted. So.
Any point of time, suppose if I'm implementing more than one interfaces, suppose it says like this particular method has to be implemented here, how do I know where? Because I don't know what that. I'm sorry. Yeah, it's just the method is. The interface
Yeah.
is just.
Well, luckily, if you're doing this with Eclipse, it'll tell you. If you do it on a command line, you'll get some convoluted message that comes out of it. This is something like error in line something or other unimplemented method.
What I wanted to ask is, I believe like there's no point when we want to relate this method which we want to implement to which interface it is related to.
Oh yeah, there's no way of telling.
And we don't want to do that also.
Do we even care?
Yeah, that's what.
When we start looking at the collections, it'll be an interesting question that you'll ask yourself. It's like, where's it coming from? Don't know, but we can create a stack. We can create a list. So, which is all about the concept of abstraction. So, any other questions before we continue on to topic number 2 for this afternoon? Nope. Okay, good. I'm gonna cancel this video here. Stop the capture.